Have you ever watched a cashier just fly through a huge pile of groceries? One item after another. Beep, beep, beep. It looks like pure muscle memory, almost like magic. 100 items scanned and bagged in what feels like just a couple of minutes. You're probably thinking the cashier is just a checkout ninja. And maybe they are. But the real secret isn't just human skill. It's some seriously clever, surprisingly simple technology working overtime, hidden right inside that scanner. It's a perfect dance between hardware and software, all designed for one thing: speed. That satisfying beep is the finish line of a tiny, incredibly fast race. In the split second it takes for that sound to happen, a whole chain of events unfolds. The scanner has to see a code, understand it, send it to a computer, get a price back, and show it on the screen. This all happens faster than you can blink. It's not one single piece of tech doing all the heavy lifting. It's a team of components, each with a specific job, all optimized to shave off milliseconds. Every part is engineered to prevent a slowdown, because in retail, time is literally money. So what's really going on under the hood? It starts with something we see every day, but probably don't think much about: the barcode. Those simple black and white lines are like a license plate for your box of cereal or your jug of milk. They don't actually contain the price or the product name. All they hold is a unique number, a product ID. That's it. The scanner's only job is to read that number, and read it fast. The rest of the magic happens in the store's computer system, which is a story in itself. The goal is to make the process feel effortless, for you and for the cashier. The less time you spend waiting in line, the happier you are. The faster a cashier can get through a transaction, the more customers they can serve. That's why companies have poured so much research and development into making this tiny moment as quick and painless as possible. It's a beautiful example of how smart, focused engineering can make a huge impact on our daily lives, even in the most mundane of places like a checkout lane. So, let's break down the tech that makes it all happen. Let's start with the scanner itself. The classic one, and the one you probably picture, uses a laser. You see that web of red lines dancing around in the scanner window? That's it. A laser beam is shot out. It's reflected off a spinning mirror. That creates the pattern of lines. The sensor inside the scanner looks for the reflection. Black bars on the barcode absorb the light. White spaces reflect it. The scanner reads that on-off pattern and translates it back into the product's number. The other type, which is becoming more common, is an imager. Instead of a laser, it's basically a small camera. It doesn't just scan a line, it takes a full picture of the barcode. The scanner's software analyzes that picture. It finds the barcode. It decodes the lines and spaces. That's why you can scan coupons and QR codes off your phone screen. A laser scanner can't do that. A phone screen doesn't reflect light the right way. For a camera-based imager, a screen is just another picture to analyze. Both methods are incredibly fast and accurate, but a good reader alone isn't enough. Barcodes get crumpled. Barcodes get smudged. Barcodes are printed on curved surfaces like soda bottles. Once the scanner's hardware captures the barcode, the software takes over. And this is where a lot of the hidden magic happens. The raw signal from the scanner isn't always perfect. A barcode might be partially torn, or a smudge could cover up one of the lines. This is where error correction algorithms come into play. The software is smart enough to analyze the incomplete pattern. It looks at the built-in checksums within the barcode and figures out what the number is supposed to be. It can essentially fill in the blanks, turning a failed scan into a successful one without the cashier even noticing. This internal software is also responsible for cleaning the signal. In a busy store environment, there's a lot of potential for electronic noise or weird light reflections to interfere with the scan. The software is programmed to filter all of that out, focusing only on the data that looks like a barcode. It's like having a bouncer for data, only letting the important information through. This digital cleanup process happens in an instant, but it's critical for accuracy. Without it, scanners would be far more prone to errors, leading to more manual price checks and a lot more frustration for everyone in line. Then there's the database lookup. After the scanner has a clean, correct number, it sends it to the store's point-of-sale system. This system's computer has a massive database containing every single product the store sells. The computer uses the barcode number to instantly look up the product's name, its current price, and any active sales or promotions. The technology is constantly getting smarter, moving beyond just reading simple lines. Self-checkout lanes are a great example of this. These stations often use a combination of scanners, cameras, sometimes even AI. When you scan an item, A camera and a scale work together to verify what you scanned matches what you placed in the bagging area. Camera close-up, scale close-up. The system knows the approximate weight and even the shape of a carton of milk. If you scan a small item but put something heavy in the bag, it flags an error. This adds a layer of security and accuracy. Machine learning is also making its way into the checkout process. Retail companies collect massive amounts of data from every scan. They use that data to train systems to read tricky barcodes better. The AI can learn from millions of examples of worn, torn, strangely angled labels. Over time, the scanner's software can actually get better at its job without a human programmer rewriting code for every problem. Fewer unreadable items means more speed at the register. Let's look at a real-world example. Imagine you're in a long line, maybe 10 people deep, everyone has a full cart of about 50 items. If advanced scanning technology saves just 1 second per item, that's 50 seconds saved for each person. For the whole line, that adds up to over 8 minutes saved. Now multiply that by all the checkout lanes in a store, and all the hours in a day. The time savings are huge. That's why stores invest so much in this tech. Those tiny 1-second improvements deliver a massive return in efficiency and customer satisfaction. And here's a surprising fact that most people don't expect. Modern scanners are preparing for a future without traditional barcodes. New imagers can read different code types like QR codes, but the really exciting tech is RFID, radio frequency identification. A tiny tag on a product can be read wirelessly, no line of sight needed. Imagine pushing a whole cart of groceries through a scanner archway, and every item rings up instantly. This tech is already used in warehouses, and it's the next logical step for retail speed.